All right, so we're basically going to use some of the stuff we've just talked about. It says the first row has 18, and the fifth row has 26. So second row, third row, fourth row, fifth row has 26. It says the number of seats in each row forms an arithmetic sequence, meaning it's telling us there is a common difference between them. So in order for that to work, then the second row would have to have 20, the third row would have to have 22, and the fourth row would have to have 24. Okay, so essentially what's happening is each row, they are adding 2 seats, right? As it gets wider, as it goes further back from the stage, there's 2 seats extra per row compared to the one before it. So that means the common difference is 2. All right, the first term is 18. All right, if we're being asked to write the explicit definition, then I'm just taking the common difference and multiplying it by n minus 1. And a sub n is going to equal that expression that I just wrote, meaning any row. So if I wanted the 8th row, right, then I would substitute 8 in for n. You get 8 minus 1 is 7, times 2 is 14, plus 18 is 32. So that means there'd be 32 seats in whatever the 8th row is. All right, let's see if what I said makes sense. All right, so again, okay, so they actually went about it a different way. I mean, I kind of figured out what that common difference was. The way they have it set up is, since you know that the 5th row has 26, that means at that spot a sub n is 26. 18 is the first row, and then 5 is your n value. Then you're just going to solve for d. You get the same 2 that we got by kind of looking at the diagram and figuring it out. That works too, but they're getting the same explicit definition at the end. Okay, so that's an algebraic way to do it. I kind of gave you a graphic way to do it. Both would be sufficient. Okay, so the next one. All right, so you notice how it's the same information. So we can use the formula that we wrote on the last example. So a sub n is equal to 18 plus 2 times n minus 1. If it's asking us for the 12th row, we're simply going to substitute 12 in for n. So a sub 12 is equal to 18 plus 2 times 12 minus 1. So it's equal to 18 plus 2 times 11, 18 plus 22, which is 40. All right, so we're getting that there's 40 seats in that 12th row. All right, so they agree. Cool. So at this point, I want you to pause, give them a try, and then hit play and see my answer if it matches up with yours. Okay, so we're going to have to figure out what the common difference is. The information that we're given is that, well, let's start with the formula for explicit formulas, for explicit definition of a sequence, of an arithmetic sequence. So you have a sub n is equal to a sub 1 plus the common difference times n minus 1. In this case, the first day, she runs 1 mile, okay? On the 7th day, so we're going to say that's that number, she runs 2 miles. Sorry, the 2 should go there. And then it's plus the common difference that we're solving for. 7 goes in for n. Okay. So now we're solving this for the common difference. 7 minus 1 is 6. So you have 2 is equal to 1 plus 6d. Subtract the 1, and you get 6d is equal to 1. Divide by 6, you get d is equal to 1/6. So that means each day that Samantha runs, she's adding 1/6 of a mile to her run. So the explicit definition for that would be, well, now that I have the common difference, I already knew the first a sub 1, so then the explicit definition would be a sub n is equal to 1 plus 1/6 times n minus 1. Okay. And then how far does she run the 19th day? So a sub 19 is equal to 1 plus 1/6 times 19 minus 1. 19 minus 1 is 18. 18 divided by 6 is 3, so you get 1 plus 3. So on the 19th day, she's running 4 miles. Okay. So again, explicit definition matches what we had. And she is getting 4 miles, or they're getting 4 miles that Samantha's running, just like we did. Okay. All right, let's look at example 4.